Hey, my name is Allison, and first of all, you'll have to excuse me. My allergies are very bad today for some reason, so my voice sounds a little bit weird, and I'm probably sniffling through the video. But today I'd like to present the differences I found using random forest and the ANOVA functions within R using a certain data set that I will be showing you later in this presentation. Here's a brief outline of what will be presented in this presentation. I will briefly introduce the two functions, random forest and ANOVA. I will then be introducing the dataset being used, and then we'll hop into R, run these functions through R, and then hop back in the PowerPoint for the very end to look at the differences seen using these two functions within R. So what is random forest? Random forest is defined in R as the classification and regression based on forests of trees using random inputs. It's a clustering method using multiple models. Is a predictor to see what variables account for the variation in data. ANOVA, or the analysis of variance. For this presentation, I will be using a fit linear model before running ANOVA. So I'll be assessing the predictability of independent variables to dependent variables. And when I say the variables, they can be categorical or continuous, or within R, they can be a factor or integers. And then once I fit the model, I'll run it through ANOVA to assess the importance of one or more factors by comparing the response variable means at the different factor levels. And like I said, now we're going to hop into Excel to quickly view the data set I'll be using for this presentation. So here's the data set. It is a data frame of a tree measurement research project on 2 sites within Tennessee, 2 tree planting sites. The species planted were cherry bark oak and swamp chestnut oak as indicated in these numerical codes. Looking at different families, which means the acorns were collected from one family was collected from one tree, another family of acorns was collected from a different tree, and then we have the measurements conducted. So 2006 was the first measurements ever done on these plantings, so I'll refer to it later as initial height. And then we have the heights and deviations or diameter at breast height for 2011, 2006, and the most recent survival. So the easiest way I know how to enter this into R is to copy and paste it. We're going to name this data frame tree because it is the measurements of trees, so why not? So we're going to do a read.table function to get this into R. And I accepted it. Here's the first top 6 rows of our data set. Because we are using functions that need to specify which variables are categorical and which variables are integers, we need to check to make sure that R is reading these variables as such. And as you can see, R is not reading these variables as we want them. We're not having the variables that need to be factors or integers and the variables that need to be integers or factors. So we're going to manually go in and change them to their correct format that we need to run these functions. Okay, all the factor variables have been changed. Now we need to change the integer variables, which are the measurement variables. So the heights and the deviations. Okay, so let's double check to make sure that we entered everything correctly. Oh, we forgot row as a factor, so let's go in there and change it real quick. Alright, so we have everything that we need to set is correct. So now let's go in and run a random forest. So we want to look at height as a dependent variable and the rest of the variables as independent variables or predictor variables. So, tree. And we came up with a huge red error. And that is because, as you can see, we have multiple levels of in our categorical variables. And the function of random forest just can't handle that much stuff. And because of that, I actually went in and I created a very simplified version of my data set that I just showed you. This one, I've taken out everything except for the site, the 2 different species, and the 3 height measurements. So again, we're going to go in and copy and paste it into our studio. So we're going to name this one Tree 2. And that is because I'm just using this simplified data set in order to show what a random forest function looks like when it's ran successfully. I'm going to use the original tree data frame to run my ANOVA and linear model in. But for the purposes of showing what a random forest looks like, I'm going to use a simplified data set. Alright. Oh, need tree 2. There we go. Well, as these has a lot less variables. I think it went from 13 to now it has 5. And we're going to run a forest. Again, we're going to have height of 2016 be the dependent variable. So let's do this again. Nope, I forgot to add trees. Always remember to enter where your data set is coming from, or R will get very mad at you. And so we got an error here because in the first data set we remembered to run the str, and this one we need to make sure that R is actually looking at categorical, and again it's not, so we're gonna have to manually go in there and change it, which is good to know. So site, at least for this one, there are a lot, if I can type, there are a lot less variables to change. Okay, hold on. Deleted too many things. There we go. Alright, and from that, okay, so everything's what it should be, so now we can go back up here and run the random forest, and now it'll work. So because we had to simplify the original data set to such a small amount of variables, from 13 to 5, with the same amount of observations, we're seeing that this random forest can only explain 35% of the variation within this data set, which is kind of a problem in this data set, but if it was smaller with a lot less categorical variables, then maybe we could see a higher percentage. So with random tree, you can, if you don't still want this output, you can get a just like an importance. Yeah, I'm gonna say, let me pull it up quick. It's easier to explain. It is a function that is in the random forest package. I gotta spell it correctly. There we go. It's just a numerical output of the independent variables and how they, basically, how important are they. You can also plot it like this graph over here, which is using bar and plot of your RF1. And so it's going to plot it with, this is it. It's just a graph representation of your random forest output. So with that, that concludes using random forest for this presentation. So now we're going to hop into linear modeling in ANOVA, and for that, again, I'm going to go back to that original tree data that has 13 different variables. So we're going to set up a place where we can summarize the linear model. So linear model is basically a function of the way the independent variables relate to the dependent variable. And again, we're going to have the height of 2016 be the dependent variable. And we're going to see how these independent variables like site and height and DVH and reference block relate to predicting this height of 2016 that was recorded. So height of 2016 is a function of, let's do height of 06 less the height of 2011 plus the DVH measured in 2011. And we're not going to worry about the DVH 2016 because that is measured at the same time height in 2016 was. We're also not going to worry about ID or tag because it's just a label for the tree that was planted. But we will look at ID and species and site. And because we're not going to look at row, because that's just helps you locate the tree a lot the same way a tag number does. But we are going to look at ref and block, but we're going to look at the interaction because for the experimental design, they kind of go together. And we ran it or accepted it, so now we can pull up a summary of what we ran. And it's a very big output because it shows all those interactions, and we have a lot of those ref and blocks. And for this output, stars equal importance. So those interactions between ref and block, we're not seeing that much importance. But we are seeing importance within the site. The most current 2011 height and DVH measurement. And so with this basic function, we can now enter it into ANOVA. So the ANOVA function is just a basic AOV you're going to set it so that you can pull the summary out later. And you will just enter in the name of your function, which we did as fit lm1, and we're going to run it, or accepted it, and then we're going to call on it again, like we did for the linear model. And let's drag this up so we get a better idea. So this is a much more simplified output than what we saw for the linear model. Again, we're seeing there's not a lot of statistical significance for those rep and block interactions. We are seeing a slight significance in the 2006, and a lot of significance in the height, the DBH, and the ID, which is the family. We're not seeing a lot of significance with the species. So just because it's a different species doesn't mean there's more about the genetic families than there is about species. So let's keep that ANOVA there, and then we're gonna bring back this random forest that we had and compare those two outputs. Okay. Okay. So as you can see, it tells you how much and the number of trees and the type of random forest it ran, and the number of variables tiered at each split. So there's 5 different tiers, and there's one thing at each split. But then that gives you a very generalized look of what you have on the ANOVA. It tells you which specific things at what value they're significant at. And with that, I'm going to hop into PowerPoint one last time to summarize these differences between random forest and ANOVA. So as I saw in random forest, I had to simplify my data a lot in order to get random forest to run it and get it underneath that 53 categorical variables. Received, to my knowledge, the much I understand random forest, you received a very limited output. Back to the limited data sizes, it's good for smaller data sets in order to get that higher percentage of variation explained, and it only gives you a very generalized idea of what's going on in the variation in your data. And ANOVA, for me, it's easier to interpret. The stars are very helpful. With ANOVA, you can look at interactions like I did in the linear model. I looked at the interactions between rep and block. I could have done site and species, because those interactions are fairly important in certain study areas, and it gives you a more precise explanation of your data, my data in this case. So for the data set I used, the winner was ANOVA by a landslide. And with that, I'd like to conclude my presentation. This is my literature cited from the quotes I used, the information I looked up in order to create this presentation. I'd like to thank Dr. Zobel for all his help in forestry, wildlife fisheries. This is class 90 or 590. And again, I'm sorry for my voice going in and out for this presentation. Have a great day, and